Hey everyone, and welcome back to our 30-day data science crash course. If you made it to day 2, give yourself a pat on the back. Yesterday was all about getting our mindset right, and today we're diving straight into the deep end, or rather, the fun end, of the pool. We're going to start writing some code, and our tool of choice is Python. You've probably heard this name thrown around a lot, and for good reason. It's one of the most popular programming languages in the world, especially in the field of data science. Think of it as the Swiss Army knife for anyone who wants to work with data. Well, for starters, its syntax is incredibly clean and readable. It almost looks like plain English, which makes it much easier for beginners to pick up compared to other languages. This means you'll spend less time fighting with confusing symbols and more time actually solving problems. Furthermore, Python has a massive community of developers who have built an incredible ecosystem of tools and libraries specifically designed for data analysis, machine learning, visualization. We'll be touching on some of those later today. Imagine you're trying to build a new piece of furniture. You could try to craft every single screw, hinge, and wooden panel from scratch. Or you could use a pre-packaged kit with instructions and all the parts you need. Python is like that amazing kit. It provides you with the fundamental pieces, but also gives you access to powerful pre-built components. We call them libraries. Alright, let's get into our very first concept, variables. A variable is simply a container for storing a piece of information. Think of it like a labeled box where you can put something. You give the box a name, and then you can put stuff inside it, take stuff out, or see what's in there. In Python, we create a variable by giving it a name and using the equals sign to assign it a value. For example, new_subscribers = 50. Now, whenever we use new_subscribers, Python knows we're talking about the number 50. Now, these boxes or variables can hold different types of data. Let's start with two simple ones, integers and floats. An integer is a whole number, 10, -5, 1000. So new_subscribers = 50 is an integer. A float is a number with a decimal point, 3.14, -0.5, 99.99. Product_price = 19.99. Python is smart enough to know the difference between these types just by looking at the value you assign. Next up, we have strings. A string is a sequence of characters. Text. You can store your name, a sentence, or even an entire paragraph in a string. To tell Python that you're creating a string, you just need to wrap the text in single quotes or double quotes. For example, video_title = Python for beginners. Strings handle textual info, customer names, comments on a blog post. Finally, let's talk about a very important data type called a Boolean. It might sound complicated, but it's actually the simplest of all. A Boolean can only have one of two values, true or false. Think of it like a light switch. It's either on or it's off. Booleans are incredibly useful for making decisions in your code. For instance, you could have a variable is_subscribed = true to check if a user is subscribed to your channel. So, we know how to store single pieces of information in variables. But what if we have a bunch of related items? Imagine you want to keep track of all the video topics you plan to cover this week. You could create separate variables like topic 1 = Python, topic 2 = data analysis, topic 3 = SQL. But that gets messy fast. This is where lists come to the rescue. A list is an ordered collection of items. You create a list by putting items inside square brackets separated by commas. For example, topics = Python, data analysis, SQL, Git. Now you have one variable that holds all your topics in a specific order. One of the great things about lists is that you can easily access any item in them using its index. In programming, we usually start counting from 0. So the first item in a list is at index 0, the second is at index 1, and so on. If we wanted to get the first topic from our list, we would write topics 0, and that would give us Python. We can also add new items to the end of a list using a method called append. So, if we decided to add a video on machine learning, we could just write topics, append, machine learning, and our list would instantly be updated. Now, lists are fantastic for ordered items, but what if the order doesn't matter and you want to store information as key value pairs? Let's say you want to store information about a specific video, its title, its view count, and its number of likes. This is where a dictionary comes in handy. A dictionary is like a real-world dictionary. You look up a word, the key, to find its definition, the value. We create dictionaries using curly braces with key value pairs separated by colons. For example, video underscore stats equal sign, title, Python basics, views, 15000 likes, 750. If we wanted to get the number of views from our video underscore stats dictionary, we would write video stats views, which would give us 15,000. As you start writing more code, you'll notice that you often repeat the same set of steps. Imagine you have a task you do all the time, like calculating the engagement rate of a video, likes divided by views. You could write the calculation out every single time, but that's inefficient and prone to errors. This is where functions come in. A function is a reusable block of code that performs a specific task. You define it once, give it a name, and then you can call it whenever you need it, just like calling a friend to help you with something. To define a function in Python, we use the def keyword, followed by the function's name and a set of parentheses. Let's create that engagement calculator. Inside the parentheses, we list the ingredients our function needs to do its job. These are called parameters or arguments. In this case, our function needs to know the number of views and likes. Then, inside the function, we write the code that performs the calculation, and importantly, we use the return keyword to send back the result. So the full function might look something like this. Def calculate engagement, views, likes. Engagement underscore rate equals sign. Likes, views, 100. Return engagement underscore rate. Once our function is defined, we can use it as many times as we want. Let's say we have 3 different videos with different stats. We can call our function for each one. Video 1 underscore engagement equal sign. Calculate underscore engagement. 15000 750. Video 2 underscore engagement equal sign. Calculate underscore engagement. 5000 2100. Video 3 underscore engagement equal sign. Calculate underscore engagement. 100,000 4500. Each time we call it, we pass in the specific views and likes for that video, and the function does the work and returns the calculated engagement rate. This makes our code much cleaner, more organized, and easier to debug. If we ever need to change how engagement is calculated, we only have to change it in one place, inside the function. Think of functions as creating your own custom tools. Python gives you a lot of built-in tools, but the real power comes when you start building your own. You can create functions for almost anything. Cleaning up a piece of text, formatting a date, or performing a complex statistical calculation. By breaking down a large problem into smaller, manageable tasks and turning each of those tasks into a function, you make your code infinitely more readable and maintainable. So far, we've been running our code from top to bottom, one line at a time. But what if you need to perform the same action on every item in a list? Imagine you have a list of video titles and you want to print each one out. Print titles 0, print titles 1, print titles 2, and so on, hundreds or thousands. That's not practical. This is the perfect job for a loop. A loop lets you execute a block of code multiple times. The for loop is perfect for iterating over a sequence, like a list. The syntax is intuitive. For title in titles. Read aloud. For each title in titles, do the following. Indent the code beneath the for line. So to print every title, for title in titles, print title. Python goes through titles one item at a time. It assigns the item to title, then runs print title and moves on. What if you don't know how many repeats you need? Use a while loop. Run while a condition is true. Example, processing a queue until it's empty. Show variable, videos underscore in underscore queue equal sign 5. Example loop, while videos underscore in underscore queue. 0, print, processing a video. Videos underscore in underscore queue equal sign 1. The loop checks the condition first. Since it's 5, condition true. Prints and decreases to 4. Checks again, 4. 0, yes. Runs again. Repeat until videos underscore in underscore queue is 0. Then 0, 0 is false and the loop stops. Loops are fundamental to programming and data science. They automate repetitive tasks, cleaning every row in a dataset, training a machine learning model, generating a series of reports. Loops transform manual time-consuming tasks into automated, efficient processes that can handle thousands of data points in seconds. Now that we have some Python basics under our belt, it's time to introduce the libraries that make Python a data science powerhouse. The first one we'll look at is NumPy, which stands for Numerical Python. At its core, NumPy provides a powerful object called an array. A NumPy array is kind of like a Python list, but it's supercharged for numerical operations. It's much faster and more memory efficient when you're working with large sets of numbers, which is something we do all the time in data science. To use it, we first need to import it, usually with the line import NumPy as NP. Let's see why this is so useful. Imagine you have a Python list of temperatures in Celsius. Celsius underscore temps equals sign 0, 10, 20, 30, 40. Now, what if you wanted to convert all of them to Fahrenheit? With a regular list, you'd have to use a for loop to go through each temperature, apply the conversion formula, temp 9/5 plus 32, and store the results in a new list. It's doable, but it takes a few lines of code. With NumPy, you can do this much more elegantly. First, you'd convert your list into a NumPy array. np underscore temps equals sign np.array, Celsius underscore temps. Now here's the magic. Because np underscore temps is a NumPy array, you can apply mathematical operations to the entire array at once. To convert all the temperatures to Fahrenheit, you just write Fahrenheit underscore temps equals sign np underscore temps 9/5 plus 32. That's it. One single line of code. NumPy automatically applies the operation to every single element in the array. This is not only cleaner to write, but it's also incredibly fast because NumPy's operations are written in lower-level compiled languages like C, making them much more performant than a standard Python loop for these kinds of tasks. Beyond these element-wise operations, NumPy is the foundation for almost all scientific computing in Python. It provides a huge range of mathematical functions for things like linear algebra, Fourier transforms, random number generation. If NumPy is the foundation for numerical data, then Pandas is the ultimate tool for working with structured tabular data. Think spreadsheets or SQL tables. The name Pandas comes from panel data, and it's the single most important library for practical real-world data analysis in Python. It introduces two main data structures: series, a single column of data frame, a two-dimensional table with rows and columns. A data frame is what you'll be working with 95% of the time. To get started, we import it with import pandas as PD. Imagine data about our videos stored in a dictionary. We can easily turn this into a pandas data frame. Dictionary field, title, Python basics, SQL intro, views, 150002200, likes, 750, 1100. Create data frame, df equals sign PD, data frame, data, print df to see a formatted table with column headers and row indices. This is the central object in Pandas, and it's incredibly powerful. First step, explore the dataset. Pandas makes this incredibly easy. Use df.head to see the first 5 rows. A quick peek without printing everything. Use df.info to get a summary of your data frame. Shows data types and missing values. Use df.describe to get descriptive statistics. Count, mean, standard deviation, min, max for numerical columns. But the real power of Pandas lies in data manipulation. Select a column, df views. Filter example, df views, 20000. Pandas allows you to slice, dice, filter, group, reshape your data in countless ways. This process is about cleaning, transforming, exploring data. Where data scientists spend the majority of their time, Pandas makes this process not just manageable, but often enjoyable. With Pandas, complex data transformations that might take hours in Excel can be accomplished in minutes with just a few lines of code. After you've explored and cleaned your data with Pandas, the next logical step is to visualize it. A chart or a graph can reveal patterns, trends, and outliers that you might miss just by looking at a table of numbers. The most fundamental and widely used plotting library in Python is Matplotlib. It's an incredibly powerful library that gives you full control over every aspect of your plots. Though for now, we'll just stick to the basics. To get started, we typically import a specific part of it like this. Import matplotlib.pyplot as PLT. Let's create a simple plot using the video data we were working with in our Pandas data frame. A bar chart would be a great way to compare the view counts of our different videos. With Pandas and Matplotlib working together, this is surprisingly simple. We can just write plt.bar d title a d views. In this line, we're telling Matplotlib to create a bar chart. The first argument, dfTitle, provides the labels for the x-axis, the different bars. The second argument, dfViews, provides the height for each bar. Of course, a chart isn't very useful without labels and a title. After creating the bar chart, we can add a few more lines of code to make it more descriptive. plet title, video views comparison, plt label, video title, plty label, number of views. Finally, to actually display the plot on our screen, we call the command plt.show. And just like that, you've created your first data visualization. This is just scratching the surface, of course. Matplotlib can create all sorts of plots, line charts to show trends over time, scatter plots to see the relationship between two variables, histograms to view the distribution of a single variable, and much more. And there you have it. Take a moment and look back at everything we've covered today. We started with the absolute basics, what a variable is, and journeyed all the way to creating our first data visualization with Matplotlib. We talked about data types. We organized information with lists. We used dictionaries. We made our code reusable with functions, and we automated tasks with loops. Then we unlocked the superpowers of NumPy and harnessed Pandas to manipulate data like a pro. That is a huge amount of ground to cover in one day, and you should be incredibly proud of yourself for sticking with it. If some of these concepts still feel a little fuzzy, that is completely normal and totally okay. Nobody becomes a Python expert in a day. The key is to practice. Try rewriting the examples we went through without looking. Think of a simple personal project, maybe tracking your daily expenses or maybe tracking your favorite movies. Create some lists, build a dictionary, write a simple function. The more you type the code yourself, the more these ideas will solidify in your mind. The goal is progress, not perfection. I'm excited to have you here, and I can't wait to see you tomorrow for day 3, where we'll continue our adventure into the powerful world of data science with Python. Thanks for watching, and keep up the great work.